This on? Yes. All right. So I'll be a rock star. Okay, so it was an unexpected pleasure to be invited to be introduced by Joe. One of the reasons I kept track of this institution and this program somewhat is that Joe went directly from Princeton to this group. By the way, if my voice does not carry because I either drop this or something, let me know. I don't want to be told at the end of the class, I wish I could have heard you better. So please promise me that. So there's an unusual feature to the speaker series, one that I'm not used to, which is to say things about oneself as well as about the material. And so I'm trying to do that along the way here. And but I have a one-sentence abstract, maybe the shortest abstract I've ever written, but I wanted to have you have something. And it's really my hobby horse, which is that we're talking about solving the climate problem and not spending a lot of time imagining what our favorite solution, how our favorite solution could go wrong, or somebody else's favorite solution that we don't like could become very prominent. And we have to have a more two-sided way of thinking about the problem as we get more and more serious here, or we'll make very serious mistakes. On my mind, for example, is geoengineering. We really have, this is the important problem of your lifetimes. We're passing the baton to the young people in the room, and that's what you're going to be doing for the next 50 years is solving climate change. And someone comes along and says, I know how to lower the temperatures, we'll put some stuff in the stratosphere. You've got to have a sophisticated argument about that. You've got to anticipate that's the kind of argument you're going to have. Not just we need to do something, so we'll take anything on that we'll do. So I started in physics. I went through a first faculty position in physics, and in the middle of that had a kind of early midlife crisis that a pure science career was not going to meet the needs I had given my upbringing and what I cared about, to be more engaged with social issues. And exactly at the time that I was most restless and running out the string in a junior professorship, the environment moved from something people didn't talk much about to something everybody was talking about. It happened in a short time period. In the end of the 69 to 71 was to kind of capture a lot of where every university had to make some response, not just in the US, felt that something new was going on. What happened in that time period? We landed on the moon in July 1969. Viewing the Earth from space was, I think, the kind of shock to our mentality. That is one of the reasons. And the other was it was the 60s with its challenging of authority, challenging of the ways. So science for the people, which I think is still with us as a phrase, kind of emerged in that time period. What are scientists doing if they're just talking to themselves? It worked on me. I then got involved with my colleague John Hart. Some of you may know him. He's run the ERG program at Berkeley with others, and he's still there. He's an oncologist. We were both junior faculty at Yale, and we decided we're going to learn this field. We better get involved, like writing a book, and we were able to do that. I'll show you in a moment. And Princeton asked me to come, as every institution was trying to do something about environment. Princeton decided to create a position for someone to figure out what interdisciplinary environmental research was. It was placed in the Department of Mechanical and Aerospace Engineering, which was concerned that it looked like a war department at a time when a lot of students were protesting, and humanities faculty were protesting the war, and they wanted to do some things that looked like peace. And I was able to get that job. And the first two projects I dreamt up, Joe mentioned one, which was energy use in buildings, and another was a siting question about building a dam on a major East Coast river. It was in the end not built. It was, I say that everything like it before it was built and everything like it afterwards was not. So that's a bit of a location of me. That's the book, Patient Earth. That's the cover. It was meant to be a reader that would supplement science courses. And of course, the title, Patient Earth, is a pun. In one sense, the patient is a patient in a medical environment, and the patient is hurting and has been compromised by our actions. It needs our attention. The other, it's not an absolute total instant crisis. You have some time. There are options we can develop and improve. Yes, it's sick, but it's not on its deathbed. No game over. We are now in a world where the phrase game over or Armageddon or apocalypse is just coming to everybody's tongues. And I think it's inappropriate still. I think you're getting, a lot of you may be feeling very depressed about your futures, whether to bring children into this world. We've got a different framing of the problem. And the question is whether the facts have really changed or we're just somehow working on each other to get more scared. We do have to do something, we don't. But the question is how much of a kick do we need in order to do something? Maybe we need to say words like apocalypse and Armageddon, but I'm not sure. This played out a little bit in that cover because the first draft from the publisher had no leaves on that tree. And I said, that's too bleak. And I remember this, it's just almost 50 years now. I said, put some leaves on, and here they are. So that's symbolic of what I'm trying to say. Wait. I see, think of it this way. I got it. Okay, so I'm also a science teacher first. And one of my observations is that we are not putting this into the curriculum, starting at 3rd grade. And so this is my little test, which was suggested to me by a friend. You ask your gas station attendant, your sister, your, I don't know, at various stages of life, why doesn't the planet get hotter and hotter when the sun is shining on it all the time? And you realize that that's actually a fairly hard question. We don't learn a couple of critical facts that are related to that moon landing, which is that we are in space and that there's something cold out there to which we can cool off, which is called outer space. It's not zero, but it's pretty absolute zero, but it's pretty low. And then we have a balance. And then you work out the balance, you can calculate temperature. Some of you have been through a lot of those calculations. This is what I call science literacy, which we have ideas of what science literacy means, and it doesn't yet include environmental science. So one of my pitches is to include that. And I've been teaching this kind of a course since I came to Princeton. And there's still not an uptake, because I teach freshmen right now. They cannot answer that question. I didn't embarrass you all to see how many of you could, but I suspect nearly all of you could, but you didn't learn it. How many learned why the Earth is in balance by cooling off to space before college? Okay, one hand is up. And that was what kind of a course?
Public primary school, like the third
What
grade.
town?
It's a small village outside of Joliet, Illinois.
So how do you explain that when nobody else in the room raised their hand? What's some inspired science teacher?
Yeah, it was a good public school district.
And a good science teacher.
Yeah, lots of them.
Very interesting. Isn't that one hand, and it's a small town in Illinois? Who would have guessed? Lots of people went to Berkeley High in this room, or Davis High, or right? Okay. The blue marble, just to remind you what it looks like. This actually is the iconic picture. It's a little later. It's in 1972, 3.5 years after the moon landing. It turns out it was the last time anybody could have taken this picture up till now. Only that they're far enough away from the planet in a capsule. And there's a cyclone over there, which had just passed over India a few days before and apparently caused a lot of damage. Comes along with the picture. Another way of describing what I'm interested in is Pasteurs Quadrant. How many of you have heard of Pasteurs Quadrant? It's a kind of it never became quite part of everybody's conversation. It was a book and a concept that's being repeated, and I recommend it to you because it answers the question, what kind of work are we interested in doing? Many of us. Don Stokes, who wrote this, said, we talk about pure and applied as if that captured the entire issue of what kind of problem solving we want to do with technical backgrounds. But it's really a two-dimensional space, not a one-dimensional space. And he said Niels Bohr was working on fundamental problems without a view toward application. And Edison was working on applied problems without a view to developing theory. He tried one filament after another to make a light bulb without any underlying guiding principles. So so Edisonian and Bohrian are the usual polarity. But he said that if you think of it as a two-dimensional space, you can work on applied problems with a fundamental approach. And then you've got a quadrant, which medicine is actually fairly familiar with, and Louis Pasteur, working on the silk industry, working on pasteurization of milk, working on a number of problems with theoretical background, understanding infectious disease and things of that sort. So we are working in Pasteurs Quadrant, many of us, I think many of you wouldn't be at university if that weren't at least one of the things that attracts you. So I recommend this vocabulary, throwing it in. And now I'm going to turn to a 2x2 quiz. And I'm quite curious how this is going to come out. Each one of you is going to vote. I'm going to ask you to vote. Do you understand the questions? Which quadrant are you most comfortable in? Where do you feel you belong? When you're answering two yes/no questions. The first is, are fossil fuels hard to displace? And the second is climate change an urgent matter? So take about 15 seconds, and I'm going to ask you to raise your hands depending on which quadrant you are happiest in. Okay, how about the upper left? Nobody. Fair enough. How about the upper right? 1, 2, 3, 4. It's fine. It's fine. 5. 5. Climate change isn't that urgent, and fossil fuels are very hard to displace. Got 5, 6 even. Okay. How many of you in the bottom left, where we have fossil fuels aren't all that hard to displace and climate change is urgent? About 2. And how many are in the bottom right? Just about everybody else. That's a very interesting, Joan?
Yeah, I'm in the bottom.
Bottom right.
Yes, yes.
Yeah. I'm in the bottom right, but I've done this quiz a lot of times, and lots of people are in the bottom left or top right. And I'd say the bottom left and the top right are the people who go to sleep at night and sleep pretty well. But if you're in the top right, the bottom left is called cognitive dissonance. You believe two things that are really in collision with each other. The top right, where a lot of, well, I'm going to go to the next slide. If you were in the top left, you could have been in the top left 30 years ago quite easily. You believe the nuclear industry was going to come and make the cheapest possible energy. Accidentally, you would solve the climate problem, but you weren't really driven by it. And fossil fuels weren't hard to displace. In fact, nuclear power was too cheap to meter. So there is such a world. And renewables may have had equivalent, may today even have an equivalent group that say it doesn't matter whether climate change as a driver or not. Renewables are simply going to come in, and we don't care whether it's important. We don't have to think about whether climate change is serious or not. We can be a climate change denier, love renewables, and end up in the top left. I just love them, have confidence in them. Top right is where a lot of people in the fossil energy industry are. I'm curious about the 6 people who raised their hands. If you believe fossil energy is very secure, dominating the energy system, say for the next 50 years, and you also believe that the climate change problem is way exaggerated, it's not as urgent as many other things, you would be in the top right. And if you'd be in the bottom left, if you really believe there was an inevitability to the renewables future, had been breakthroughs that had dropped the costs, and so fossil energy is just going to get elbowed out or shoved out the door in short order. I would say the Green New Deal perspective is kind of in the bottom left. And in the bottom right, you can't sleep well at night. You believe 2 things that are really in collision. There's a child's game called The Immovable the irresistible force encounters the immovable object. What happens when the irresistible force tries to push the immovable object? Yeah, it's kind of a, what's the word? Is that right? They call these kinds of puzzles. Okay, so anybody want to comment on this matrix? There's one book that calls it Socolow's Quiz. I'm kind of proud about that. Anybody want to comment on that? Yes, sir.
What's your definition of urgent?
I wanted you to decide. You voted for the top right. What was your definition of urgent?
Well, actually, I meant top left, but.
You meant top left. Okay. But so you didn't think it was, so say what did you think urgent meant? I'm asking you, what did you think urgent
You
meant?
have to define some metrics for it.
I'm having trouble hearing you.
Well, you have to define some metrics for it.
Oh, yeah, I agree.
Within a time span, how much is it gonna cost? And if I don't start today, what are the implications in
Fair
terms
enough.
of like number of casualties?
So I encourage you all to talk through the word urgent. Most people were ready to have a different view of it than you, but that's fine. We can talk it out. Yes, one more comment.
Just on the idea of urgent, I mean, if it was easy to make the transition, I wouldn't feel as much urgency as I do. It's the fact that it's hard that makes me feel a sense of urgency, because there's a lot of work to do to get where we need to be, because fossil fuels are hard to displace.
You would be more, yeah, okay. That makes sense, that they're not independent as I'm pretending they are. Fair enough. But most of it, nonetheless, located yourselves one place. I've added temperatures in here to create an argument where these futures that are essentially today's official international objectives, every country signed on to, the goals of having very low carbon futures, shutting down the fossil energy industry in no more than a few decades. And if we do nothing, there's some high emission scenarios that come out at 4 or 5 degrees Celsius. And nobody talking about this middle ground where we don't meet the goals, but we also don't achieve the worst outcomes in terms of climate change. But that really may be, it's not the way people talk about this, which is why I'm trying to find things for this talk that have that feature. Okay, so is that right? All right. So another autobiographical slide that leads into the rest of the talk. First of all, a physicist discovering environment lights on energy. The butterfly lands on the energy flower. And so that was a field that didn't exist. The word energy was pretty much not used as a general word. People worked in nuclear issues, they worked in coal, they worked in hydropower, but energy emerged. In Russia, the Europeans call that energetica, or energetique. And it doesn't still exist in departments, but this is a program that has got energy in it. Got transportation and energy, right? I think that's right. So I'm kind of guy with a physics background, look for general principles. And 4 recent papers over the last 15 years, I'm dividing my talk into 4 sections, one on each of those papers. They all go beyond technology and science. And some people know that I kind of like languages and I can talk a bit of a lot of them, but I don't know any of them well. I realize the same thing goes for the way in which I've taken on the science, social sciences and humanities. I know the vocabulary, I often collaborate more effectively with lots of others, but I don't know them very deeply either. But that's called problem driven. And so there are stabilization wedges, which is what Joan mentioned at the beginning. 1 billion high emitters, I'll tell you what that's about. Committed emissions and destiny studies. They're all sort of catchphrases that I introduced. So this, as Joan said, the key paper that got us going, and it was top of the charts in terms of anything I've done in my life. I didn't realize that was happening. But we've had 3,000 citations and whatnot. Al Gore has it inside his movie, Inconvenient Truth, inside his book and movie, Inconvenient Truth. So it's, how many have seen the Wedges story somewhere before? Probably more, quite a lot. Okay, so I'll go very fast. It's kind of amazing that it had got into the school system the way that cooling of the planet to space has not. How come? I don't know. So it starts with looking back, realizing that emissions have grown. The paper was written in 2004. If it were written today, you can get it pretty much right by just extending the yellow line at about the same angle, and you'd have the same story. Or to make it simpler, we just relabel these dates here. And you'd have because it hasn't really changed as a story compared to then. And all that's based on the right is to ask two questions. One, if we pay no attention to climate, we're in the upper first or second quadrant, what are emissions likely to be? We said 50 years from then, 2054, we could say 50 years from now, it's 15 years later, 1/3 over. And the other question is, how well would we have to do to feel good about ourselves? And that's an interesting question indeed. And we answered both questions to get the conversation underway. And then we started saying, well, so that there's a lot in this graph. I wanted to save time, you know it all. So we drew a line that essentially doubled emissions from fossil fuels in 50 years as what we think what would be baseline. That still, even today, is kind of the high emission scenarios approximately do that. Then we said something which today sounds quaint, which is that if we did nothing but if we managed to keep the emissions from climbing at all, but that's not demanding that they drop, we could celebrate. 50 years from now, we could have a big party. We had really done something hard. I actually still think so, but the argument has been taken over by others who say that is nowhere near good enough. You should have a scenario at least of cutting emissions in half in 50 years. This is global emissions. And better yet, you can try to get them phased out in 50 years. So our paper could be thought of today as nowhere near the ambition that the world actually wants. How many of you heard the Wedges paper presented that way when you in class? Maybe some of you did, but it really is important that we were outflanked. And people no longer can even talk about taking 100 years to get the problem solved. First level them out in 50 years and come down. If you're on here, the CO2 emissions are going up in the world because the natural sinks don't come close to knocking those out. So the carbon concentration keeps growing. And if you follow here, then you can talk about the 400 ppm now, it would be 450 maybe here, maybe 400, let's say 450, 500, 550 or something like that, and going up. So that was the, and then we added that we took that green triangle and we broke it into segments and said these can be parallel campaigns, parallel strategies. We gave them a name, stabilization wedges, and it allowed. And what were we doing? We were being ecumenical. Let me fill this in. So a wedge, we did it in tons of carbon, put it in terms of tons of carbon dioxide. Instead, it's only a 10% difference. Today, everybody's talking tons of carbon dioxide. So 4 billion tons of carbon dioxide not emitted into the atmosphere in 2069. 2069, the world is not emitting 4 billion tons of CO2 that it would have emitted thanks to something we've done along the way, a strategy, a campaign, okay? And then those are called wedges, and we can talk about a wedge of energy efficiency or nuclear power or wind or whatever. And that's and we drew triangles. I remember I contributed nothing but straight lines, no curves, no exponentials. We want to talk to people who understand the area of a triangle, but they don't understand e to the x. Stick to triangles, and we did. I think that was one of the reasons we succeeded. And so that particular triangle has 100 billion tons of CO2 in it. And a typical price in the climate game to get actual significant action, and a reference price in my head anyway, is $100 a ton of CO2. Multiply those two numbers, you get $10 trillion for the activity. That's a lot of money. And that's the scale. These wedges are very big activities, plus the fact that it's growing. And so The Scientific American article 2 years later, they said, we want to keep your wedges, but we want new graphics. And they drew this. We had 15 proposed wedges, and here they are. The same ones that we had originally, which are the ones we've just been mentioning. A couple of them biological, which reduce deforestation, burying carbon and building up carbon in soils. And then a blank for the one to stand in for all the ones we might have used and didn't. And summing up, my friend David Hawkins says, the reason this was popular was that everyone could choose their own iPod. Does anybody still have an iPod? Or anyway, it's got a new name. What should I call it these days? It wasn't iPod in those days. You could pick your favorite music and you could play it anytime you wanted. And you stored, maybe you don't store a finite amount of music anymore anyway. It's all up in the cloud. You can play anything you want. So this dates it to 2004. But prepare to negotiate with others who have chosen their different things. We kept nuclear power on the list. There were people who said, don't put it on the list, you're just going to encourage it. And I said, we have to be, the point of this is not to take sides, to show what the physical option space really amounts to, and let people duke it out from there. So many people over the years have asked Steve and me to rewrite the wedges paper. Surely you have something new to say, which wedges did well, which ones did better, and over again I pushed back. Partly out of laziness, and partly because I didn't feel I had something new to say, and partly because I really wanted to work on other things. I didn't want to be a one-paper guy, which I probably am anyway. So only a year and a half ago, I was asked to give a public talk at Princeton, and I had an aha. I said, I know what I want to do to add to what we've said so far. And I showed that. Here's a horse race, and the horses are coming out of the starting gates more or less side by side. What is that metaphor saying? And that's 2004. It's saying that I don't know who's first, who's going to win this one. There are lots of options. They truly seem all plausible to do very well. I think that's really was my state of mind. And what do you think the next picture will be? A horse race, mid-race. They've spread out. Now we have a new game. The wedges game was itself. Wedges itself was a game where you picked your wedges that were your favorite wedges. Here I'm asking the question: which wedges have done best? Which strategies have done best, and which ones have not done so well? And there's again it's a matter of opinion. But who would like to name the two front runners? Anyone? Solar, and anybody else? Huh?
Natural gas.
Can't hear?
Natural gas.
Natural gas? Arguably, yes. Anybody else? No?
Efficiency.
I heard wind, I heard efficiency. They all have to come in here somewhere. I put solar and wind in front. They have done remarkably well. And then we kept going. Now there's one horse way in the back over there. You see it? Over there. And so I've been asking, I actually thought I knew what it was. And a year and a half ago, I'm very unsure of this now. And it's because I learned a little bit more. I put hydrogen fuel in the back. It seemed to me that compared to its promise in 2004, it was so much diminished. There's, I think out of the 15 wedges, we have 4 of them involving hydrogen. Hydrogen made from wind, hydrogen made from natural gas, hydrogen for power, hydrogen for transport. It was playing a big role. We were hydrogen enthusiasts. Joan was part of the group. Joan was Miss Hydrogen. And it seemed to me it's much less discussed. Since I did that, I learned that Japan and South Korea are very much still involved with hydrogen transport. And so my question overnight to myself was, if I concede in this room that that's wrong, hydrogen has done better than that, is there any wedge that I would say belongs that far back? And I would say no. I would say that our view of what was in the competition is still really that everything is in the competition. That horse is not in the competition. Arguably all the others are. So we went on, and Two that we thought were really going to be very important are kind of near the back, both nuclear and CCS, in terms of what we hope, but the advocates of the technology believe they could accomplish compared to where we are now. I think they're pretty far back and kind of similarly underperformed, and similarly are trying to deliver very large projects. When you try to deliver a very large project, there's a lot of costs, there's lots of opportunity to major cost overruns in both cases in real projects at very large scale. Kemper for CCS and the South Carolina plants, Georgia plants and nuclear. Fission coal, supercritical coal, and gas for coal, which I think was way up there in the front. And the biological versions of things are not as far along, maybe. Certainly there's more promise of biofuels, people's minds in 2004 than today. And efficiency on the outside, ready to make a move. Okay, and then one more. We didn't have storage on our list. We sort of thought it would take care of itself. We knew it was there. We multiplied numbers by 3 to say how much wind, or how many gigawatts of wind displace a gigawatt of coal. Well, 3 to 1, and then we left it at that. But clearly, storage technologies would not be left off of a discussion of a paper like this in 2019. So let's go through some wedges quickly, because I want to get to some other stuff. They come in all places. The efficiency wedges come in all places, and arguably the LED light bulb is as important an invention of the last 15 years as anything on the supply side. Tremendously important. And this is cogeneration, and this is public transport. This is a variable speed drive motor playing a role in industrial energy efficiency. And this is an intriguing one that's really part of our world, which is the ability to substitute traveling of bits for traveling of people, and having working from home, essentially, and much reducing personal transport. So that's sort of the efficiency landscape in one slide. I keep thinking out. And then we have this important sector. I don't know where it gets worked on in university. You have a transportation group there. As far as I know, there is no equivalent group in buildings. Lawrence Berkeley Lab is the closest to it, but 70% of US electrons produced in power plants end up in buildings, and the world is 60%. And the world is building these major high-rises for apartments as billions of people are leaving countrysides for cities. They're going into buildings like that. An enormous implicit energy consumption and carbon emissions, and almost no attention to this phenomenon. That's a particular town outside, a residential community outside Beijing. I have no idea how efficient the buildings are. I had only one probe once where I discovered that every disease of inefficiency in the US was being copied in the developing world. First cost emphasis rather than life cycle analysis, split incentives, renter and owner. Our litany was still alive and well and being copied into the developed world of enormous significance to the carbon problem and not being worked on. Solar power. 5 questions. I wrote a report with others that on my website you can find your way to something called the Distillist Project. We have 5 reports, one on batteries, grid scale batteries, one on nuclear reactors, small modular reactors, one on magnetic confinement fusion, one on solar, and one on wind. So from the solar one, these were the 5 questions I came away with as wanting to think about more. This interesting dichotomy of the same panel, 300 watts, 3 feet by 5, sitting in the desert and sitting on a roof. About 1 million of them in the desert and 10 on a roof. And what's the future of solar? What balance of those 2 futures are we talking about in California, in the world, and everything in between? I think this is a rich question. There's a political power comes for the decentralized version. People like it. They want to be part of it. The cost is much lower for the centralized. How does that play out? Do they mutually reinforce? Is one going to win? What about in other countries? how much balance of system costs can be reduced. We have I think the way to think of solar power right now is we have a free panel. We have a free panel, and now we're trying to make electricity from it, run the world on it. What do we have to think about we haven't thought about before? Can we just do that? We just roll out enough panels, overbuild, so we don't even have to worry about storage, and just have it all there when we need it, to make everything electric, and then work back from there. What do you have to give away? Well, crystalline silicon is completely dominating the market. Is that a permanent feature? All sorts of scientists are working on alternatives to alternative photovoltaic material. Is it too late? How will intermittency be dealt with? Is it going to throttle the development? And how much public support is needed and will be available? Is the era of subsidies for solar over? Just throwing it out. For wind, I want to share one line of argument which I personally pursued, which has to do with looking into lulls. For solar, day-night problems, 12 hours of storage, it's pretty clear batteries are going to be able to do that. But as you go to longer time periods than one day, it's not so clear what strategies we have to deal with the difference in the amount supplied, either for a bunch of cloudy days or a bunch of low wind days. So what this figure is the wind power output for the state of Texas, or more explicitly the ERCOT the ERCOT system, which is most of Texas, in 2016, hour by hour, and it has 17 gigawatts of installed installed wind power and 6 gigawatts average output. And the question I asked is, pick a number randomly that represents low wind, and let's say it's 3 gigawatts, low wind output. We're not even looking at the wind speed, we're looking at the output. And then start at the left and start every time the power output in Texas for wind power dropped below 3 gigawatts. Start a clock ticking and count hours until it comes back above it. So you start from left and you see that there's maybe a very short interval here, and there were 4 long periods. The 4 longest periods are shown. 3 of them are 2 days long and one is 4 days long. Just I would love to see this repeated on lots and lots of other databases. I haven't found a partner to do it. I did this first with Pedro Haro, who was on his last 2 or 3 days at Princeton. He did it as last thing. He's a professor in Seville, in Spain. So this is what we need to think about. What happens if that's the whole power system of Texas? How is that dealt with? This is the histogram that shows this is the number of percent of the time that a lull takes up. And when there's one lull, it's on this. When there's one such incident, it's on this line. And you see those 4 events. And this is particularly the longest one. It was probably backed up with natural gas in Texas. And nobody much paid it attention. Well, I say something provocative and forgot that was here. Gas, solar, this word should be there, and gas wind packages where natural gas is just burned and there's no CCS, would take care of this problem. You can run the world on medium carbon emissions on solar or wind, and gas doing the rest of the work. And the gas is going to do the intermediate. Solar and wind can produce power whenever they can, and gas supplements. We can't do that with 100% renewables, a zero emission objective. We can if we then add CCS, but then they're not as flexible, but maybe they're still the right answer. So I find that lull analysis something that needs to be developed further, and that particular way of doing it is so easy. Some of you could write that program in 5 minutes. I can't, but there's a counting routine even in Excel to set it going. And then you can see how it works. CCS, this is a figure from a Scientific American article in 2005 called Can We Bury Global Warming, which I wrote, but it was from a community of people working in CCS, Sally Benson, Julio Friedman, others really kibitzing on exactly what we wrote. So kind of a community effort. And we realized that people were not visualizing the precise amount of carbon dioxide that a coal power plant would produce, and then what sort of shape, what sort of volumes below ground were required, and what would they look like below ground. Well, this particular coal power plant on top has been running for 10 years. It's 1,000 megawatts. And here are the CO2, we call them lily pads, which are two-dimensional structures in fairly thin seams, spreading out, occupying kilometer scale volumes, aerial extents, based on assumptions that are pretty straightforward. But the biggest one was, what fraction of the brine can you actually displace with the CO2? And we picked a third, which is a very ambitious objective. I'm not at all clear you can come close to that. Nobody had done that. It's spreading out, 10 years, 60 years, power plant's going to take 6 times that volume. Arbitrary decisions about how thick the seams were, but you see the calculation. And then the message is, this is an enormous volume of material to be handling. And the footprint below ground, the size of the earth is pretty large, and so they're going to get into each other's ways. If the power plants are near each other, unless you pipe them around somewhere, it might be nice to find 100-meter thick capped formations and so on. And you get a way of thinking. I'm trying to present simple ways of thinking about problems that should be more on our minds than we are, and that which you can actually deal with. And then turning these volumes into barrels of oil allows you to talk to the oil industry. One of the findings, of course, is people know 1 unit of energy, but there are loads of them. And if you, sometimes say I'm paid to convert units. And so that this particular phenomenon would be that you would need 3 trillion barrels of CO2 actually injected below ground. And that's, in terms of an oil field, it's called a super major, what's the word, super fields? And, or gas volumes, again, they think in terms of trillions cubic feet, those are the units the gas industry uses. And you get a sense of how big that is. So we have a CO2 infrastructure already in the country. This is out of date. There's many more miles of pipeline. If we're going to have a zero carbon US, and it's going to be including fossil fuels, there would be a major CO2 infrastructure, many times larger than this, but we have the world's largest CO2 infrastructure at this time, related initially to some policies that subsidized domestic oil production, and that led to a tertiary recovery. And so that's a pretty impressive beginning toward a CO2 infrastructure. On the other hand, there's a real conversation now that we're not just trying to solve climate change, we're also trying to end the fossil fuel era, and CCS is the way to keep it going. And ipso facto, it shouldn't be allowed, even if it solves the climate problem. That argument, I think, is being joined. The Green New Deal explicitly says we want no CCS because it keeps the fossil energy industries around, and we want to close those down. So we have a question of which is more important. Do we want to do both? CCS is an extremely interesting option because it gets all that conversation into play. That's part of that 2x2 matrix before. My little model of thinking about this problem is that the carbon comes out of the ground attached to 2 hydrogens, like two little children coming along with an adult, and it goes back underground with 2 bodyguards bigger than it is, which are the oxygen molecules, which change the hydrogen molecule. Hydrogen atom from oxygen atom takes up more space. The density of supercritical CO2 is close to, but less than, the density of oil. And so you get very large amounts of volume flow, and that becomes, you're talking about an enormous infrastructure. Yes, sir?
Does that oxygen come from the atmosphere?
Sure did. I mean, you burned it. This is a flame. There's a flame on where that black arrow is.
I see. Oh, this is what was going back down into storage.
Yeah, this came out of the ground. This is going back onto the ground. It's much bigger, so you need more. So if you can't shove the same carbon back in the way it came out, so you need more volume for this to stay even. Yes?
What about the energy inputs necessary to get to actually handle that CO2 and like pump it back into the ground?
The energy to pump this down, it's significant, but it's relatively small. I don't have a number, but guess that you're in the 10% range for the extra increment. So I don't know how many of you spent any time understanding CCS. I mean, it's an industry like oil and gas. You have to prove fields. You have to verify that they work. There's new places you haven't known it. You get dry holes. Not black holes, dry holes. So my summary, which was in that abstract, is every solution is dangerous and complicated. And we haven't just, I left out nuclear power. This is a condensed version of a course I teach. Nuclear power does make nuclear weapons more likely, and we can't have a solution in the US that isn't global, I believe. Any country will want to do whatever we do, and so nuclear power's Achilles heel, there are two others, which are accidents and waste management. But by comparison, I think the possibility of a trade nuclear war for climate change has got to be much more on our minds. We can make the world safer, but we have to make nuclear weapons less appealing and less available. We're not even talking about that. Biocarbon, I'll come back to that in a minute. Competing uses of land, that certainly includes for biofuels. Geoengineering, clean coal, which is wind and solar, and conservation. Conservation and regimentation, what do I have in mind when I say regimentation? Conservation. Anybody have an example come to mind about how we could have efficiency go wrong? Or at least create lots of obstacles and pushback around the word regimentation? Yeah.
I mean, it could be really high expense, and it could be implemented in a way where people aren't seeing the returns, the long term.
You're thinking entirely in economic terms.
Sure.
Okay, but what, yes?
Is it more like you could be constraining people's personal liberty?
Like what?
By over regulating who can use energy and who can't for at what time.
Do you have a couple of examples to make more vivid?
Switching out the air conditioner.
Like the type, if there's, like hospitals can use energy, these users can't if you're using more than a certain amount.
You might have a quota,
Yeah.
you said.
Switching off people's air
You
conditioners.
might have air conditioning that was only allowed a certain number of days a week. We had a 55-mile-an-hour speed limit after the oil embargo in the 1970s, all over the country. But you could use fuel more efficiently if you had cars that were not driving 75 and 80. Was not popular, especially in the West. And we're rid of it. The Germans, with all their interest in energy, have never put on a speed limit on the Autobahn, if I'm not. Is that true? I shouldn't repeat it. Still true?
They have speed limits when you approach exits.
Exits, but not in the open. So you go 120.
Yeah, so-
Yeah, so we have an obvious place, but that's curtailing freedom. President Trump took after a particular curtailment of freedom a few months ago. Do you remember what that was in terms of energy use? Huh?
Lighting standards?
The incandescent bulb. People have a right to use an incandescent bulb. We have no business banning that. That's the tip of the iceberg from rationing of all kinds. We have to get that right. We could easily get it wrong. We have to be self-conscious. Even the incandescent bulb was sufficient to get a significant fraction of America willing to say that that was taking the government was going too far. Let it be free choice, but not ban it. We can't ban efficient refrigerator. We can't buy an inefficient refrigerator today. And the Lawrence Berkeley Lab is the hero of that, because they worked with the industry to gradually take poorly performing appliances off the market, across appliances, by agreement of the industry. A true libertarian would say that's taking government too far. You shouldn't have been able to. Those conversations shouldn't have happened. They did have government working as a third party in those decisions. And they've gone all over the world. You can't buy a really inefficient refrigerator, I think, anywhere in the world now. So just quickly on what I mean by conditionality, which is if these things could be done badly, what do you have to demand of the solution so that it isn't done badly? The technical word in the international policy discussions is conditionality. What's the conditionality to add to an efficient car, efficiency or a nuclear or a geoengineering or a wind objective? So for biocarbon, here's my question. I think some of you working on biofuels can relate to this. What will go wrong if we move headlong to maximize global biocarbon stocks? In this case, we're trying to put carbon into trees, let's say, by growing more trees. you're a forester or an agronomist, and the carbon price is very high, and you're told that storing carbon in the biosphere is your objective, and you're getting paid to do it well. What would you, and based on the tons you're putting away, what would you do? And there's no other rule. You might establish a monocrop, you might pour on fertilizers, be inventive. I really want to see this game played with people who really know what they would do if they were foresters. They would do all kinds of stuff. So, change roles. You're the policymaker, you want not to have ecological damage past a certain point, and you're going to add conditions on the way in which you build up biostocks so that you would welcome the outcome and not regret it. So I think that applies across all of the options. This is what I mean by the solutions really needing their own independent inspection. Most climate change talks that you're going to hear about are going to be about damage impacts, not about this side of the story today. It seems to me. I may be wrong. I'd love to know that. Come on, you had 3 talks last year. 2 of them said the same thing you did. Well, that'll be fine. I should know it. Tell me afterward. And then geoengineering on the list. Mentioned it briefly. You know, all know anybody not know what that picture is about? Be honest. So, okay, so good. There are a few. So this is a picture of Mount Pinatubo, 1991. No volcano has been that large since then. There have been many much larger ones earlier than that. But that one was big enough, and we were sentient enough to learn a lot from it. It was big enough to send particles all the way into the stratosphere, which takes a lot of injection velocity, more than most volcanoes have. And those particles got up into the stratosphere and stayed for the order of a year. And while they were up there, they were reflecting sunlight, and the planet noticeably cooled over the time period of a year or so. The particles eventually fell out of their own weight, and the planet went back to the temperature it had been. But we actually counteracted global warming with particles in the stratosphere by an act without any direct effort on our parts. So this idea is do it on purpose, do it with balloons or rockets or airplanes of special design, get up into the stratosphere, leave particles up there, and they will reflect sunlight and cool the planet and counter the warming of greenhouse gases. They fall out in a year, you say. They do. So go up there regularly, steadily, year after year after year. That's the geoengineering, one version of geoengineering. Others make clouds brighter, but it's the same general idea. So just having, I don't want to spend any more time on that because I want to keep moving. I'm going to skip that. So a summary is a version of the Hippocratic Oath. Some of you know that's what doctors take along with their license. They affirm that they're willing to abide by this rule, and the rule is, in short version, is do no harm. The longer version, one version of the law, which strikes me as applicable to what we've been talking about, I will apply for the benefit of the sick all measures that are required, avoiding those twin traps of overtreatment and therapeutic nihilism. What does all that mean? Imagine maybe many of you already had this, the younger you are, the possibility you've escaped it, of having somebody important to you, possibly yourself, very sick, confronting experimental drugs, whose side effects are known to be severe, and having to decide whether to use them or not. You and the doctor and family members try to make that call. To some extent, and that's what Patient Earth as a title of the book was about, this is where we are. The solutions, if you think of them as dangerous drugs that can easily have side effects, even unanticipated ones, and the planet as being sick, you get close to this picture. So therapeutic nihilism means I wish we could do something. I'm sorry, there's nothing we can do at all. And overtreatment means you're using drugs far too freely than you should. And so you're navigating between those two rocks. Okay. And how am I doing on time? Because I've got only one.
We've got 20 minutes left, and we'd love some time for questions.
So let me just quickly just show you what these other 3 are about. You'll have the slides available somewhere. I think this was the core, but I did add a lot of other stuff. So, well, I assume most of you have a sense of carbon diaries, how much emissions go with various types of activities. Many of you know the average for the world is 5 tons of CO2 emissions per capita per year. The US average is about 15. China's around getting up there. A country like India might be around 2. And you can identify your 5 ton per year emissions with some kind of a reference set of activities like driving, flying, heating a house, or having lights on. And then I mentioned that I assume this has been done for the campus as well. And at least at Princeton, the number is about 9 tons of CO2 per year, just the campus energy divided by the campus population. I assume you all know the number for Davis. And if you don't, this is as good a group as any to probably find the calculation of measurements of a few years ago and make them known again. Bakala and Chakravarti and Tavoni and I and 2 others gave ourselves the following assignment. There are 7 billion people on the planet. There's 35 or so billion tons of CO2 emissions. Let's figure out, let's allocate every one of those tons to somebody. So there's no overlap, nothing left out. We did that with income distributions and carbon intensities of countries. And after we did that, we said, well, how much emissions do people have? We assume carbon dioxide emissions are roughly proportional to wealth. We sometimes use the power law. And we get a picture that about 1 billion people are emitting more than 10 tons of CO2 a year, twice the global average, and account for about 2/3 of the emissions are on the right, the people are on the left. The top bar is what I'm talking about, and it's like so many other unequal distributions in life. It's another form of inequality. About 2/3 of the emissions are coming from about 1/7 of the population. The two parts of the bar there are 2003, where the data came from, and 2030, which is where the extrapolations, various models, all mostly agreeing, showed. So you get this extreme, you have, the title of our paper is 1 billion high emitters out of 7 billion people. And high is not Elizabeth Warren's wealthy. It's almost all Americans, the average European and up. It's a much larger group than that because it's 1 billion people. Where do they live? That's the top group, and that's the division into 4 parts of the world, where the US and other OECD, US and China are blue and yellow. They're about even in 2030, and more than half of the emitters are outside the OECD, the Europe, US, Japan, Australia, combination of countries, the so-called developing world. More than half are there by 2030. And the developing, with a very small group, I'll get to that in a minute, but just notice it, it's almost entirely in the non-OECD, non-China world. So there's a productive way of thinking about the problem, which I call going beyond per capita, going beyond and be aware that the UN pretty much, anything involving the UN pretty much forbids you to look inside a country. You only see per capita data from UN reports, in particular in this field. And so you don't easily learn that half the emitters are going to be from the developing world. And I would argue more generally that the next billion emitters, when we go from 1 billion to 2, will be almost all from the developing world. So this is a global problem where most of the people live in the developing world and are developing. And we are not spending anywhere near the fraction of the effort we should be on understanding the development choices, the energy choices in the developing world, the carbon choices in the developing world. For example, if anybody in this room can tell me, I would love to know, I've been asking, what are the half dozen issues that will determine whether India really develops on the basis of a lot of solar versus coal? And it's got that option, and it's got that optionality ahead of it at this time. How is that going to come out? Leapfrogging. I made that graph before a talk in China because I knew that word would probably not be able to be translated by the translator. And the developing world is jumping over the industrialized world in order to do things for the first time. There are many examples of that, but there will have to be many more. And then this is the same issue about the 7 billion people distributed over by emissions. This is 10 tons of CO2 per person per year. This is 8 billion people. And this is the population that is using less than 1 ton of CO2 per year. And the green is their actual emissions. Actually, this idea comes from Jones and my colleague, Bob Williams. Suppose that you put a floor under CO2 emissions at 1 ton of CO2 per year, and they would therefore, the world would have extra emissions from the poorest people, These might be motorbikes, these might be diesel engines in villages. You would have to work harder to meet any given target. Here a target was defined, it was, I think, some specific emissions per year, and it was achieved by drawing a horizontal line and leaving the blue area as the accomplishments. We would essentially, we wouldn't literally put a rationing top, but if you did, it would look like that. If you add the red, these two red areas are equal. So you have a 10% extra effort for the world, the wealthier people, the middle class, to allow meeting of Millennium Development Goals, which put some kind of, this kind of removes abject poverty. You have that much access. Now, does it have to be fossil energy? It certainly doesn't. But the point is, it could be fossil energy and we'd have to work only a small amount harder. I gave this talk years ago at a World Bank context. They said, tell your donors from the industrial world insisting that there be no carbon emissions, that we spend no money on solutions to the poverty that involve carbon dioxide emissions, because that's setting people down the wrong path. I said, but some places you could do diesel engines in 5 villages for the cost of renewables. Less true now, but still, it doesn't matter. We're not going to be allowed to do it. So there's an important issue there in terms of equity. I didn't want to bring that up. Committed emissions. It's a paper by Steve Davis and me. And the top picture is the top left picture. Just look at those five rectangles. When we build a power plant today, in almost all carbon accounting, we talk about its emissions year by year. That's the net. There is another accounting strategy or practice where you would say, I'm going to charge all the emissions the power plant will emit to the year it comes online. And that would have a stack of 5 green rectangles instead of 5 horizontal blue rectangles. And then if it had run a while, I could make the distinction between the emissions that had happened and the emissions that were still left to happen. So when you take that and you take a power plant database of the world, and what Davis was able to produce was the committed emissions for all the power plants running at that time that were still left, the committed emissions that were incurred by the power plants in a given year, and then whether at this later point they had been realized, these had already been shut down, these were still running, these were left to happen. So you get a view of what we have in the way in the tank, what emissions that will happen. We have to make one extra assumption. How long is the power plant going to run? So we took the 40-year reference, and you can vary that and see what happens. So that was the overall strategy to introduce the concept of committed emissions and realize from that reference system how important the decision in India to build coal power plants is. It doesn't show up in the normal way in which we'd be counting to. Unless you think they're going to get retired early, and there's enormous momentum not to. And of course, early retirement then becomes part of the conversation. Focusing on committed emissions is another way to enlarge the conversation. And that's where it takes you. The coal power plants dominate that story, and China plant. This is a little out of date. The role of the countries coming behind China, especially in Asia, is even more important than there. Finally, the destiny studies. That means a lot of things. I have too many slides to get through, so let me just see which ones I want to pick out. I'll skip that one, skip that one, skip that one. I haven't shown this slide to a group before. How many of you saw this picture in your education? This is really very interesting to me. It has come into the young people's education. My students in my class have all seen it. It's become an icon to explain what we are embarrassed about. The high schools, maybe junior high schools in America are telling their students that we once upon a time were bad. It's a really extraordinary thing. And we're bad in the sense that here is America moving from right to left, from light to darkness. She has around her right arm, dangling from it. Can you see what she has there? Anybody? She has a loop of something. You're a little far away. She has a loop of telegraph wire. And it goes from there to her other hand and over to these poles. She is laying telegraph wire westward. And what's going on here? Native Americans are running away to the west. What's going on here? Bison are going away to the west. This is an 1872 image that was iconic in the opposite sense. 100 and how many years? 140 years ago. And now the classes are all being they're being browbeaten. You guys are being browbeaten. We must never do this. We mustn't be proud of it anymore. It's an extraordinary flip. I showed this to a group of people talking about the future of the Amazon, realizing that Brazilians have this very choice ahead of them right now. The new head of this country, Bolsonaro, is kind of a manifest destiny guy looking northward instead of westward and saying, we don't need those forests. Let's get on with development. So I think in destiny studies, we really need to visualize alternatives, futures. And we have a big head start in this country because this picture has been popular. Imagine if it hadn't. Imagine if that were the argument we have to talk, do we really want this? Well, maybe we do. We don't actually have that argument in this country. Maybe we'll come back. Maybe it is there and I'm just not even recognizing it. I'm going to skip this. I do want to talk. My final. So we're looking at carbon, maybe looking at carbon budgets. The idea that temperature rise is ultimately dependent on how much carbon we use altogether, and therefore it can be various times, various places, for various purposes. We have never had a problem like that. This is a leave it in the ground discussion. We can't produce anywhere near the carbon we have. And we have no way into this problem that's at all easy. And why am I still an optimist? Many, many people in this game are not. I wish there were more. We have a terribly inefficient energy system. That's what you work on, and you know it's true. The cost of solar and wind power have fallen precipitously, which opens up all kinds of new options that we haven't thought through. Most of the physical plan for 2069 in the world, and a good fraction of the infrastructure in the US, if we're going to go to a zero carbon world, has not been built. And above all, very smart young people now find carbon and energy problems exciting. And that's my number one reason for optimism. Thank you.
All right, we have about 5 minutes for questions, and then I'm sure we'll run over that.
I'm not going to hang around after that.
Yeah.
What happens if we go 10?
Yeah, I was going to say that we always run over. So,
Okay.
so let's get the questions rolling.
Yeah, I may take 2 or 3 at a time so we get more people asking. Yes.
In your study where you looked at the periods when wind diminishes for extended periods of time,
The low analysis?
the wind analysis,
Yeah, low. I know. Yeah.
analysis, and I've seen similar things too when people talk about long-term storage, about are we going to plan for that like 2% of the time where the wind and the sun really doesn't shine.
Go on.
And in California, we have this new thing where we're de-energizing lines and people are becoming more experienced with blackouts. And I'm wondering sort of the adaptation. So do we really have to solve for that possible 2-3 day power outage, or is that a place to adapt and it become a new normal?
So I'm going to answer that before last. I love that question. It's one of my favorite questions. The engineers in the power system have been taught for decades that their job is to get that light switch to work no matter what is happening outside. Is that something which is not appropriate to a world which is running on power sources which we do not have under our control? Or can we have social change which says, you know, a 4-day lull, and we kind of know it's coming because we've gotten good at weather prediction. We will actually adapt. And I was looking for examples of that, and someone said, you know, there's one in plain sight. Now, maybe not here, but there's something called the snow day. Do you all know what a snow day is? The kids don't go to school because there are not enough clouds to get the work. And so we accept it. We let nature drive our parents' days off of work, charged against their vacation time very often because they have to be home. All that disruption is accepted because we don't think we need to spend that extra money on snow plows to have so many of them ready to go that particular day, or move the school by 6 hours, or do something else that would be very disruptive. We just let it happen. There must be other examples like that, but not many. But basically, we want to run a world that we don't have to be responsive to nature. Is that something we will actually trade away? If we are, it's complete change in the norms of lots of the people educated in engineering and in the power sector more generally. Other questions? If you work on that, I'd love to hear more. If you don't work on that, it's like, yes, sir.
Going back to your grid about whether you think fossil fuels are hard to displace.
My 2x2.
Yeah. So when you put the 3 degrees Celsius in the lower right, I
Yes.
was a little confused by when you say you're in the lower right, are you saying that because fossil fuels are hard to displace, you're resigning, you're saying the best we can do probably is 3 degrees, or are you saying?
I am saying that. I would say when the best you can do, given the disruption that will come from trying to go faster. And of course, that's heresy. You're almost not allowed to say that today. It's like saying certain bad words. But I have a feeling it would be safer to accept 3 degrees. I do have a picture that I skipped over. Maybe I can find that about 2 degrees and 3 degrees. Yeah. So there's a simple-minded way about thinking about emissions that came out in the last decade or so, where you realize that cumulative emissions drive ultimate temperature rise pretty nearly to first order, and that it's linear for small amounts of temperature rise, so that and a coefficient that is arguably adequately described by 1,600 billion tons of carbon dioxide emitted for 1 degree Celsius rise. We have, in fact, emitted about that amount so far from coal, oil, and gas. We have had about a 1 degree Celsius temperature rise. And in fact, the fossil energy era doesn't look so different from a linear climb from 1940 to 2100. Of course, it really looks more like that, but it's like that. So what's a 2 degree scenario? It's doing the same thing down on the other side immediately. So this is a 2 degree scenario. By 2100, the fossil era is over, and by 2060, we're half the emissions. That's how I showed you a 2 degree scenario with that same point a little while ago. So it's not a bad, you can see that I really like these abstractions. Not a bad way to think about 2 degrees, what the world is actually asking for. There's errors all over the place, but that's not bad. And where we're heading is not straight, but what we had in our witness paper, we're still heading up. The yellow arrow is what's happening. What's a 3 degree scenario? It's taking a rectangle with area of 1,600 and slotting it in between the two triangles. Today, I didn't say this, but today's emissions are about 40 billion tons of carbon per year, which is why 80 by 40 triangle gives you 1,600. Now you slot in a 40 by 40 rectangle, and you've got your 3 degree scenario. It's easier. It's still very hard. It's certainly not yet accepted. One of the things that I'm concerned about is if we realize we're not going to achieve this, do we despair? Do we say game over? Do we also jump and drown ourselves? Or do we say, that would be hard too, but maybe it's what we should really, what we can accept. We're not there right now. That's not the dialogue. The wedges dialogue was like that. It's gone for now. But just wanted to see what it looks like. Does that help?
Yeah, it just seems, I guess to me it seems like even though it's very hard to aim below 3, that the moral stakes are too high for people.
You're asking a very important question, which is what is a goal? And an aspirational goal is surely this. Don't want to give up now. Don't even want to. And what other kinds of goals are there? Are there goals that you really intend to meet versus goals that you let? There's a nasty way of saying this talk is cheap. California says no carbon, net carbon 0 by 2046. Is that an aspirational goal, a goal that people are really going to drive toward with heart and soul? It will be both. You guys build up your electric charging station infrastructure. You do it starting now. And you don't look at whether you're going to get to 2 degrees or 3 degrees. It's a job for the present time. And then you go sort through the various options and see which ones you might let up on, but maybe nothing gets let up on until you see what's really hard to do. You guys, I will bring no expertise to this conversation. I bring a vocabulary. Yes?
I just was kind of thinking about your horse race analogy.
Yes,
And to the extent that, we are kind of reliant on, significant technological development to realize a lot of the solutions.
yes,
What makes a horse win a race is like the quality of the horse and also the training and, all these other things.
yes.
So are the different horses in the race, are they getting kind of uneven training? Are there issues sort of inherent in the research process, the industrial process that are kind of giving some horses not enough of a shot?
Absolutely.
Is there a solution?
Well, is there a problem? It's an unequal world. Should we have distributed all our effort equally among all the horses? What does that mean? I mean, government budgets would have been identical, subsidies would have been identical. We didn't. We have not subsidized nuclear power. I might get into an argument here as much as renewables in the last 15 years. There are a lot of subsidies of nuclear power, so I'm not even sure about that. What have we not invested in? We certainly haven't invested in deforestation to the level of preventing deforestation as much as we have in solar and maybe nuclear. So you can ask why they're spread out, and that becomes an interesting conversation. Pacala takes that same picture and he says, I'm interested in what we need, what the answer needs to be now, where they should be relative to each other now to get the zero carbon at the end of the century. So he puts nuclear further forward, and CCS further forward. We need them to be better and stronger than they are right this minute, he says. Yes, back there, first you.
So,
I guess you both asked questions already, but go ahead.
Oh, well, does anybody
Go
who
for
hasn't
it.
asked?
Go for it.
So you mentioned the Green New Deal and its kind of ideology of zero carbon and not accepting solutions from the fossil fuel industry at all. And I was wondering what you think about the Green New Deal's explicitly tying climate change solutions with economic inequality.
I bring nothing extra to that conversation. I think it's about how valuable are coalitions and which ones work and which ones don't. And I can argue both sides of that one, and so can you. Yeah.
So following up on that analogy question,
Which question?
the horse race analogy.
Horse race. Yeah.
So the assumption is that all those horses have the same potential.
Well, I think the argument I was making is they seem to me that they did in 2004. Now we know more.
So you basically assume that all of those horses could actually win the race.
At least be up. They might all finish in a dead heat, but there was none that was going to be unable to compete, certain not to get near the front. And now I'm saying in 2019, I've really thought about this the last couple of days because I've been feeling on the defensive that hydrogen fuel is done so poorly. I think I'm wrong. So is there any horse that really no longer looks like it has the potential to be in the final group?
Well, my question is, shouldn't you be normalizing the achievement of each of those horses based on their initial potential that you?
Okay, suppose I did. What about that picture is particularly on your mind that you must?
Because you're ranking the technologies based on what how much achievement they have in terms of reducing the emissions. But the fact of the matter is that their potential was different. So some of them might have.
Which ones had less potential in your mind? Which ones had more?
I'm not talking about any specific.
You're not talking about anything specific. Okay.
The reason I'm asking is because this is going to make the policymakers are going to use that in terms of incentivizing a specific industry or not. And I think the potential for improvement should be included in the.
Sure. So what I'm saying, I'll give you this answer, which is a little glib. The set of horses is an image, it's like a Rorschach test. The name of the game is name your horses, but the question that you're naming them about could be various alternatives, like which one has had the most subsidy, but what the question I'm specifically answering in the picture I showed you is which ones have done best in the 15 years. Not asking how come. Now that's just one question. You can change the game. I said, Pacala has changed the game. Yeah, it's a different question, shows the same picture. And I think you have a different picture in mind. Which ones had the most promise in the beginning, I think is your question.
Yeah.
And my own view was none of them was to be ruled out at the beginning. I think I really did look at them as more or less side by side in that first image. Yeah. Somebody has an answer. Yes, 1, 2. Yeah.
I just had you briefly touched on geoengineering, but
Yeah.
it's like one of like my personal like fears of climate change is that as people get more and more depressed, it's like, well, the only thing we can do is like really change our environment in some drastic way, and like, how can we prevent against that kind of?
Tell me.
Yeah.
No, seriously, I mean, this is, your professional lives are gonna go at least 50 years from here. It's hard to believe the geoengineering argument isn't gonna get engaged pretty heavily in that 50-year time period, and it's hardly begun. So you have thought about it a little. Tell us what you have to say. I'll give you the mic.
I mean, I think that I think we have, as we've shown in this like presentation, or you've shown, we have the power to do some pretty large scale damage to our environment. And we're not doing it intentionally in most cases. So I mean, I think we have the power to change our environment, obviously. I just don't think we have the power to do it in a way that takes into account every possible repercussion. So I think anyone can do geoengineering, so I'm worried about it becoming not a government sponsored task or something like maybe one group could take it into their own hands or something. So I'm just concerned about kind of the way that we treat geoengineering as a solution, as opposed to the other solutions you've mentioned.
I think it's qualitatively different.
Yeah, I mean, I do think it's different. I mean, they're each different, I guess, but I think it is qualitatively different because it has the potential, I guess with nuclear, it has the potential to do the most damage as a solution, as a potential solution, but I don't know.
Yeah. Well, you identified one of the issues, which is, could it appear in a very disorderly and disorganized way with a rogue actor country or even a rogue actor individual who, my sense is that's pretty unlikely. There's enough international pressure to get in the way of somebody who tried to do that on a large scale. So I tried to jump to, it works. I mean, people, at least there's an interest in it. Countries have figured out an international mechanism to decide how much to do. That will be very difficult because make the world colder or warmer, less warm by a little or by a lot. But let's suppose it all happens. We will not know everything about the planet when we embark upon it. And then what goes wrong? I don't want to take more time with that question, right? Well, if we don't simultaneously remove the greenhouse gases, let them build up and continue to counter them with geoengineering, there's something in this subject called the sword of Damocles, which is from Greek mythology when somebody's got a sword over their head. The particles stay in the atmosphere, in the stratosphere, only a year. Suppose we lose the capacity to keep putting them in. That's the sword of Damocles. We could lose it because we became disorganized. We had an international mechanism, but we started arguing with each other and we lost the capacity to keep something underway. Or because it's a side effect was discovered that had been missed until, say, 30 years into this, that turned out to be quite serious and we really did need to stop. More CO2 emissions we have, there's 100 billion tons of CO2 going into the atmosphere each year. We've been protecting ourselves by having a lot of negative extra reflection of sunlight. Then we stop, we get a huge sudden impact. So we mustn't imagine this as an alternative to emissions, but something to accompany emissions. Just make sure that one's out on the table.
Ryan, you had a question?
It would not be redundant, so you can provide.
Yes.
Just kind of following up again on the horse race example. The question, what was occurring in my mind when John was asking is, instead of picking a horse, somebody might apply a policy that sort of is agnostic, such as like a tax on carbon.
Carbon taxes tend to be more agnostic than subsidies, yeah.
So what role do you think that plays?
Well, one thing that's happened,
Subsidizing technology.
yeah, one thing's happened in the last 15 years is we have not gone to market mechanisms. We have not put in taxes much and cap and trade much, but we have done a lot of subsidy. And arguably wind and solar have been the principal beneficiaries of all that subsidy and have come to the front and produced a new world where we might have the option of using only them. And if we can't, we need to figure out how come. But we did choose to pick winners, as the phrase goes. in spite of every economist in the world telling you not to. And we've done all right with it.
So, Ben, did you have one final question you wanted?
Basically,
Excellent.
the verbatim question.
Well, I think all the questions just demonstrate how great the talk this was and how engaged everyone is. So let's give Professor Socolow a hand.
Thank you. We continue. This is
yeah.
not a conversation that is over.
Yeah, and we love to give gifts to our seminar speakers, but this is an extra special one. So this is a notepad, a book, a journal from Art Rosenfeld, who's a great sponsor of our Energy and Efficiency Institute when it was a center. And so we reserve these for speakers we think present visions the way that Art Rosenfeld was able to.
You may not know, but Art was one of my closest friends.
We did that. Yeah.
Thank you very much.
So yeah.
So do you want to stop the Zoom? Can you stop the Zoom? Yeah, thank you.